to another video. So in this today's video, let's see this interesting question. Find all continuous function f of x other than f of x is not equals to 0. Satisfying the equation, we have that integral right there, and then we're looking for all continuous function that's going to satisfy that integral that we have right there, that equation that we have. So what's the first thing I have to do? So the first thing I have to do is, let's rewrite the question. So I would rewrite the question. So I have integral going from 0 to x of f of t. The t is equals to f of x, and then I'm going to square that minus f of 0, then square. Now the first thing I noticed about this question is that f of 0 will be a constant because I have an input value, and then my input value would be 0, and then the output value I'm going to get will be f of 0. So at the end of the day, that f of 0 would be a constant. So this f of 0 is a constant. And then I know that if I differentiate a constant, it will give me 0. So it would always give us 0. So the first thing I want to do for this question, I want to differentiate both sides with respect to x. So let's differentiate both sides with respect to x. So I have my integral going from 0 to x of f of t, the t, and this should be equals to, then if I differentiate this with respect to x, I have this squared minus, we differentiate that expression with respect to x, we have that. Now the next thing I'm going to do is that we know that if you apply the fundamental theorem of calculus, so let's apply the fundamental theorem of calculus to the first what we have on the left hand side. So if you apply the fundamental theorem of calculus, we are gonna get f of x. So applying fundamental theorem of calculus, we're gonna get f of x on the left hand side, and this would be equals to differentiating this. This is like applying the chain rule. So if you apply the chain rule to that, so let's say chain rule. So if you apply the chain rule to that, what are we going to get? So of course we know that we need to bring down the 2. So I'm going to bring down the 2, and then I will differentiate what I have inside the parentheses. So if I differentiate f of x, I'm going to have f prime of x. So I'm going to have f prime of x. And then, I need to subtract 1 from 2. So if I do 2 minus 1, I'm going to have 1. So I'll have my f of x left. Minus, I just said, if you differentiate a constant, this would give me 0 because, that's an output function. So it will give me 0. And then the next thing I have to do, so my next step will be that I have my f of x is equals to 2 f prime of x, then f of x. And then the next thing I have to do, let's divide both sides by f of x. So let's divide both sides by f of x. And let's divide this one too by f of x. And then for this question, I will put a restriction that f of x should not be equals to 0, because if f of x is equals to 0, that question is not going to make sense anymore, because anything divided by 0, if you put that in your calculator, it's going to tell you undefined. So let's put a restriction on f of x. So our f of x should not be equals to 0. So if I divide that, I will have this one to be 1, and then this one to be 2 f prime of x. And then I can divide both sides by 2. So if I divide both sides by 2, then I should have that my f prime of x should be equals to 1 over 2. Is that what the question asks us to find? No. Remember, the question asks us to find or continuous function f of x. Now we have f prime of x. Now the next thing I'm going to do is that I'm going to integrate both sides. So let's integrate both sides. So if I integrate both sides, I have integral of f prime of x dx is equals to the integral of 1 over 2 dx. And then we know that if you integrate a constant, all we're going to do is we are going to add x to that. So if I write my answer, then I have this one to be f of x is equals to 1 over 2 x plus c. And then in this case, we know that our c right there is our constant of integration. Is our constant of integration. In fact, what we just got in, we will say that this is called the antiderivative family of all antiderivative of a function f. They are called indefinite integrals. So these are called indefinite integrals. And then for my final answer right there, I would put a restriction. There will be a restriction on that c should not be equals to 0. Thank you so much. See you in the next video. Bye.